Okay guys, we're working on the chapter 9, comparing linear, exponential, and quadratic functions review. So our last test of the year before final exams, so let's really nail it. So the first kind of question we have to classify, we have to explain why it's that, and then we have to write the equation. So first things first, let's find our differences. So 10 to 7 is negative 3, negative 3, negative 3, and negative 3. Well, that's good. If the first difference is the same, then we know it has to be linear. Okay, so good to know. So our classification is linear. And our reason is the first difference is the same. Okay, now the equation, right, if we need y equals mx plus b, that's good to know. So all we need is the slope, and we need the y-intercept. Well, the y-intercept was the x value is 4, so there's our b is 4. And then the slope, it's decreasing by negative 3. Okay, so we get y equals negative 3x plus 4. Okay, the second question, classify. Well, from 0 to negative 3, we have negative 3. From negative 3 to negative 4, we have negative 1. And from negative 4 to negative 3 backwards, we have to add 1. And then we're adding 3 again. Okay, well, all these are different, so it can't be linear. So now let's go to the next one. Negative 3 to negative 1 is 2. Negative 1 to 1 is 2, and 1 to positive 3 is 2. So it's got to be quadratic because the second difference is the same. Okay, so the first difference makes it linear. The second difference makes it quadratic. So second difference is the same. Okay, the equation. We can always use the x-intercepts. So look right here. Notice how both those y values are 0, so that makes it an x-intercept. So obviously, if x is equal to negative 1 and x is equal to 3, then we can write them as the factors. So I can write x equals negative 1 as x plus 1, and x equals positive 3 as x minus 3. Okay? We could also check with the actual y-intercept. Well, here's the y-intercept. That's at negative 3. If I multiply 1 times negative 3, that gives me negative 3 to check with my y-intercept. Okay, last one. 30 to 15. Well, if you want to think about the second difference, you could always go with addition, subtraction, or you can look at the multiplication. I'm multiplying by 1/2, multiply by 1/2, 1/2, and 1/2. Okay, so if I write that, that's got to be exponential. Okay, their explanation could be common ratio. Okay, you could also look at first and second difference. They will be the exact same thing. Okay, so the equation, we always start with the y-intercept, which is 3.75. And then our growth factor in this case is 1/2, because it's getting half as big each time, raised to the x power. Okay, let's try some of these. These should be a little easier, okay? Classify, we have our exponential. Okay, you can just look by the graph. Okay, question number 5, we have our linear. You could look by the graph. You could say curvy L for number 4. You could say a line for number 5. Question 6, got to be quadratic because it's a parabola. But the equation's tough. Okay, so the equation has to be y-intercept first for question 5. So that's at positive 2. Okay, in parentheses has to be the growth factor. So if at 0, my y value is positive 2, I'm going to figure out where my y value is at 1. I go up to 3, 4, 5, 6. So how do I get from 2 to 6? So from 0, 2 to 1, 6. Well, I multiply by 3. So that's got to be my growth factor. Okay, for the line, let's start with the y-intercept. So the y-intercept, so my b is 3, and my slope is I go down 1 and to the right 2. So my slope is a negative 1 over positive 2, x plus the y-intercept, which is 3. Last but not least, we can always use our x-intercepts for a quadratic. So if this is x equals negative 2, and x equals positive 2, I can write them as the factors x plus 2 and x minus 2. So y equals x plus 2, x minus 2. I know it doesn't look like quadratic, but if I distribute x times x, I'm going to get that x squared. Okay, now the last is the matching. Always go with find the lines. So let's start with our linear graphs, a and f. Okay, well, it's got to be either 7, because it's exponent of 1 up here, and it's got to be either 9, because it's an exponent of 1. Now look here, you could always look at the y-intercepts. They're different. So which one has a y-intercept of negative 4? Well, that's got to be a. And which one has a y-intercept of positive 2? Well, that's got to be f. Okay, next let's go to the exponentials. b and C. Those are our curvy L's. Well, one is decay because it's getting smaller and smaller and smaller, and one has to be growth because it's getting bigger and bigger and bigger. You could also look at the y-intercept. Look at how high the y-intercept is in the letter B, and where the y-intercept in C is just 1. So decay means that the growth factor is less than 1. Well, the only one that has that is 11, so that's got to be B. And look at the y-intercept, positive 10. Okay, good. And C, by process of elimination, and because it's growth, because the growth factor is 2, has to be letter number 8. Last but not least, letter 12, you have 2 quadratics left. You could look at the y-intercept. Okay, right here, the y-intercept is positive 1. Well, D doesn't have a positive 1 y-intercept. E does, and remember that the lead coefficient in the quadratic means it's going down if it's negative. So that one has to be E. By process of elimination, this has to be D. If not, you can always solve for the x-intercepts, positive 1 and negative 1, which are right here and here. Okay, next step. Okay, second page. Graph which one, and you have to figure out all the important information. Well, number 13's got to be a line because it has an exponent of 1. We'll start with the classification. It's linear. Y-intercept is always that constant, so it's negative 5. The growth factor, a line does not have a growth factor. It does have a slope, though, which is 1/2. X-intercepts, we'll have to figure it out. There's never a vertex for a line. So we start at negative 5. Okay, then we follow the slope up 1 over 2. Up 1 over 2. And then we graph our line right here. Okay, if I need to solve for an x-intercept, I have to actually plug in 0 for y. Okay, so I plug 0 in for y, and I solve for x. Add 5 to both sides, so I get 5 equals 1/2 times x. If I want to try to get a dividing by 2, that's 1/2 to both sides, I have to multiply by 2 to undo that. So the 1/2 and the 2 cancel out. 2 times 5 is 10. And if you'll see, this graph's going to go all the way out here, actually at a positive 10. So my x-intercept is 10, 0. Okay. Number 14, this has to be exponential because the exponent is 0. So it's got to be exponential. It has a y-intercept, and that's always that first number not being raised to the power of x. The growth factor is the number being raised to the power of x. There is never a slope, never an x-intercept because it's always never going to hit that x-axis at 0, and there's not a vertex. So let's start graphing it. Start at the y-intercept, which is 2, and then I'm going to multiply each y value by 2. So I'm going to get to 4 next, then I'm going to get all the way up to 8. And if I want to go 1 in the other direction, instead of multiplying by 2, I'm just going to divide by 2, which is 1. And then I have a few number of points. Remember, it's never going to cross that x-axis, so please do not make it cross that x-axis. Last but not least, the one that we struggle with the most, so let's get some space over here. Okay, the quadratic. Okay, it's a quadratic because it has an exponent of 2. Okay, classify, quadratic, nice. Y-intercept is always this constant right here. That's one of our points. Good. The growth factor does not have a growth factor. Slope, it doesn't as well. Only a line has a slope. X-intercepts, we have to factor. X squared plus 4x plus 3. So what multiplies to 3 and adds to 4? Well, x plus 3 and x plus 1. Okay, positive 1, positive 3, multiply to 3, and add to 4. So now I can solve for x. So I get x plus 3 equals 0, x plus 1 equals 0, so I get x equals negative 3, and x equals negative 1. Those are my two x-intercepts. Good to know. Let's plot them. Negative 1, negative 3. Okay, last but not least, the vertex. Okay, the vertex is always opposite of b over 2a. So opposite of 4 over 2 times 1, which is negative 4 over 2, which is negative 2. That's my x value. And I'm going to plug it in wherever I see an x to find the y value. So I'm just plugging in wherever I see an x with negative 2. Negative 2 squared is a positive 4. 4 times negative 2 is a negative 8, plus that 3, the constant. 4 minus 8 is negative 4, plus 3 is negative 1. So my vertex is negative 2. That's the x value we found with opposite of b over 2a. And then the y value is negative 1 by plugging it in. Go over negative 2, down 1, and I should start to see this u being formed because it is a parabola. I know that was quick, so if you need to review and go backwards, please rewind the video. Okay, last but not least, I'm going to set a few of them up, I'm just going to show you, but then you got to finish some work, okay? So here we go. Classify first. Let's start with 16. At the strawberry farm, it costs $3 to start, so there's our y-intercept or our initial value, and then 50 cents for every strawberry. So it's not taking a percent. It's going up by 50 cents every single time. That is constant, so it's got to be linear. Okay, we have our y value and we have our slope. It's going up by 50 cents each time, so that's our slope. It's 0.50 because that's the slope. And then it starts at $3, so plus $3. Okay, next, if you want to do f of 10, remember we're plugging that in for x. So y equals 0.50 times 10 plus $3. And then you can solve for what that comes out to be. Okay, so it should be about $8. Okay, so if I want to figure out what that stands for, I'm saying if it costs $3 for the bucket and then 50 cents for every strawberry, and I plug 10 in for every strawberry, that's saying 10 strawberries cost about $8. So 10 strawberries costs about $8. Okay, let's try the next two. Zombie population starts with one infectious person but grows 3%. Okay, percent of it, so it's got to be exponential. Okay, we start with 1, so there's our y-intercept, and it's increasing by 3%. So remember, if I want to write that, it's got to be 0.03, and because it's increasing, it's 1 plus 0.03 for my growth factor. Okay, so we start with the y-intercept, which is 1 person, and then 1.03 to the x. Okay, the growth factor is increasing by 3% each time. If I want to find the number, I plug 10 in for x, so I get 1 times 1.03 raised to the 10 power. So that's saying if it's going daily, that's what I'm plugging in 10 for. So after 10 days, whatever number comes out there, that's how many people are now infected. Okay, letter 18, or number 18. A culture of single bacteria triples. Single bacteria is telling you how much you're starting with, okay, and it's tripling. You're multiplying by 3 every single time, okay? So it's got to be exponential again. It's not going up by a number of bacteria, it's multiplying by a certain amount, which is tripling it. Okay, so y equals the numbers we started with is 1, and then it's tripling, so the growth factor is 3 to the x power. If I want to figure out how many hours or 10 hours later, I'm just going to plug in 10 for x, and whatever you get, saying 10 hours after that, the single bacteria has now become a certain number of bacteria. Okay, guys, take a look for y and do what you got to do. Test is on Monday in class, last test of the year before final exams. Good luck.